To start, let's draw a diagram to visualize the given information. We know that train X travels at a rate of 60 miles per hour and that train Y travels at a rate of 50 miles per hour. Further, we know that at the beginning, train X is 20 miles behind train Y. Therefore, the gap between them is 20 miles. Now, ultimately, train X is going to catch up to train Y and then overtake it 10 miles. So in this case, the gap between them is going to shrink. To address this type of question, let's look at what happens after 1 hour. Now, after 1 hour, train X will have traveled 60 miles and train Y will have traveled 50 miles. After 1 hour, the gap between them will therefore be 10 miles. It will be 10 miles because train X will have covered 10 more miles than train Y. Now that we know the gap after 1 hour is 10 miles, we can infer that the rate of gain of train X is 10 miles per hour. In other words, every hour, train X catches up 10 miles on train Y. Now that we know the rate of gain of train X, we can use the formula rate of gain times time equals total gain. In other words, if we take how quickly train X catches up to train Y, multiply it by how long they travel together, we'll be able to determine the total number of miles that train X gains on train Y. So now let's put in the information that we know. So we know the rate of gain is 10 miles per hour. We don't know what the time is. That's what we're trying to solve for. So we'll multiply by t, where t represents time. Now, what about total gain? Total gain represents the number of additional miles that X travels on top of what Y travels. Now, if X starts 20 miles behind train Y and ends up 10 miles ahead of train Y, X must have traveled an additional 30 miles. In other words, X's total gain on Y is 30 miles. Now, we can solve for t. Divide both sides by 10 and arrive at t equals 30 miles divided by 10 miles per hour. Simplify and arrive at t equals 3 hours. Therefore, the answer is C.